I'm going to be investigating constructing triangles in GeoGebra. So we're going to construct 3 different triangles: a right triangle, an isosceles triangle, and an equilateral triangle. So first I'm going to do the right triangle. So I need to construct it in a way that it's going to hold the properties of a right triangle when I drag it around. So to do that, I know that the definition of a right triangle is that there is one 90-degree angle or right angle. So I think I can do a perpendicular line to create my angle. So I'm going to construct a line segment, and then I'm going to construct a perpendicular line through there somehow. I don't need point C. So now I have this 90-degree angle, and so I can just add a point anywhere on this line. And so now I'm going to use my polygon tool to connect the triangle. And now I can hide this perpendicular line because I don't really need to show it anymore. And now I can measure the angle. So here we have a 90-degree angle, so it's currently a right triangle. And so now I'm going to check. So no matter how I move it, it's always 90 degrees at this one point. So by constructing a perpendicular line and adding points to the lines to construct a triangle, it will always be 90 degrees. So now I'm going to do an isosceles triangle. So the definition of an isosceles triangle is that 2 sides are of congruent length. So thinking about this, I know that when I construct a circle with a center, anywhere from the center to a point on the circle is going to be the length of the radius. So I can construct a segment from A to B. And then I can just put another point anywhere on the circle, and I can take my polygon tool again and construct a triangle. So now I can hide the circle, and when I measure the lengths of the triangle, we see that AB is going to be the same length as AC. BC is not going to be the same length, and it doesn't have to be because it's an isosceles triangle. And so now we can check and see if it holds. And so as I move it, AC and AB are always equal length. And if I show my circle again, we see it's the same length because the circle gets bigger and smaller as we move the triangle around. Well, I guess I have to show the circle again. Make sure everything's showing. Okay, everything's shown again. So I see that because I'm moving it, it's moving the circle, and these lengths are always going to be the same because they're connected to the center, so these are always going to be the length of the radius. So that is my isosceles triangle. So now I need to construct an equilateral triangle. So as with the isosceles triangle, I know that a circle is going to be really helpful. So I'm going to go ahead and construct this line segment. And so to make an equilateral triangle, I need all 3 sides to be congruent. So if I construct a circle with center A and radius AB, and then another circle with center B and radius BA, the circles have equal size radius. And if I put a point where the circles intersect, C is equidistant from A and B. So I know that CB is going to be the length of radius of circle B, and CA is going to be the length of the radius circle A. And since I constructed the two circles used in the segment AB, the radius of circle A is the same as the radius in circle B. So this should give me an equilateral triangle. So I'm going to construct my triangle with the polygon tool. And now I'm going to hide my circles. Oops, didn't mean to do that. So hide my two circles. And now we need to measure the lengths to C. So AB is 3.3, BC is 3.3, and AC is 3.3. So now once again, since I use the circles for my construction and they're going to be the length of the radius, when I move the points around, we see it stays an equilateral triangle. And if we show the circles again, we see it's because it's always the radius of the circle is what dictates the lengths of the triangles. And that's how you construct triangles using GeoGebra.